All right, off to a little bit of a late start today, but that's okay. Only a 10-minute late start, but that's still a late start. You've already made decent progress to the island, but the storm came in faster than anyone expected. When you take evasive action, unfortunately, the navigation computer seems to be malfunctioning. Rather than giving a route directly to safety, it produced extremely circuitous instructions. They have to use the PA system to ask if it can help because volunteer. Navigation instructions is a sequence of single character actions paired with integer input values. After staring at them for a minute to figure out what they probably mean. N means north, S means south, east means west, turn left, turn right, move forward. Ship starts facing east. Only the left-right actions change the direction the ship is facing. The ship is facing east. Blah, blah, blah. The instruction will be handled as follows. Blah, blah, blah. The instruction the ship's Manhattan distance is 25. Figure out where the navigation instructions lead. Okay, so I feel like we had this problem basically last year. And so if I were really smart, I would just reuse that, but I'm not going to do that. From typing import named tuple, class action, which is a named tuple, which is an action, which is a string. I'm not going to use it. I'm not going to bother with an enum. That's a little bit silly. The left, right, and forward is an optional string. No, forward 10, right 90. But they give a number of degrees. That's interesting. Action string, and let's say amount, which is an int. And let's say class ship, which is a named tuple, and a ship has a x, which is an int, and a y, which is an int, and oh gosh, this north, south, east, west. So I'm gonna call it yeah, I'll call it x and y, and that will and it has a heading, which is an int. And it starts by facing east, and x equals 0, y equals 0, and then we will say, we'll use degrees like on the unit circle. And now, if the ship is facing east and the next instruction is N10, the ship would move north 10 units, but would still move east if the following action were F. And you know what? I'm going to, after my rant about data classes, I'm going to use data class and just mutate things because data class class ship. Okay, and def move self action, which is an action, and it's going to be none. So if action dot action equals north, self dot y plus equals 1, elif action dot action equals south, self dot y minus equals 1, elif action dot action equals east, self dot x plus equals 1, elif action dot action equals west, and these are not plus equals 1, self dot y plus equals action dot amount, action dot amount, and self y plus equals action dot amount. Elif is west, self dot x minus equals action dot amount. And now we have north, south, east, west. We have elif action dot action equals left, then self dot heading, and if I turn left, that means my angle is getting bigger. Self dot heading equals self dot heading plus action dot amount, and then we'll mod by 360, and then elif action dot action equals right. So right, we're turning that way, so we'll say that self dot heading equals self dot heading minus action amount mod 360, and otherwise if action dot action equals forward, then now we're going to integer values for the value. Let's make sure that all the lefts and rights are multiples of 90 degrees, and it looks like they are. So okay, so now we say if self.heading equals 0, self.x plus equals action.amount, elif self.heading equals 90, self.y plus equals action.amount, elif self.heading equals 180, self.x minus equals action.amount, elif self.heading equals 270, self.y minus equals action.amount, and else, raise value error f bad heading self.heading, and then else raise value error unknown action. Okay, so that allows me to move, and now let's again do a static method def parse, which gives me a raw, which is a string, and what do I want to do? I want to say return action of raw 0 and int of raw 1. Okay, so that's good. And so now I'm probably not going to write a function for the rest of it. I'll just, sort of do it explicitly. Let me copy this while I'm here. And put it that. And now let's go and run our unit tests. And let's say raw is that actions equals action dot parse line for line in raw dot split on new lines, ship equals ship for action in actions ship dot move action, and then assert ship dot x equals east south, east 18, south 8, east 18, and assert ship dot y equals -8. And this is capital ship. Okay, so let us try running this, and that passed, so that's good. And now let's go and do our main. And again, actions equals action dot parse. Maybe I should have made this in a function, but I didn't feel like it. For line and raw dot split on new lines. Ship equals ship for action in actions ship dot move action, and then print Manhattan distance will be apps of ship dot x plus apps of ship dot y. Okay, so let us try this. 1482, and that's our answer. Okay. Before I can give the destination capture, as the actual action means we're putting back the instructions all the time. Almost all the actions indicate how to move a waypoint, which is relative to the ship's position. Action N means to move the waypoint north, waypoint south. Action L means to rotate the waypoint around the ship left to the given number of degrees. action R means to rotate the waypoint or forward to the waypoint number of times equal to given value. So all right, so actions are the same, but now what I'm going to do is I'm going to create another class. Let's call it ship and waypoint. And now I'll do ship x, ship y equals that. And this is ship heading, I think. And the waypoint starts at x equals 10 and y equals 1. So waypoint x equals 10 and waypoint y equals 1. Okay, and so we're going to start with all of this, and now we need to redo the actions. So now north, south, east, and west all move the waypoint, right? So this is self dot waypoint y moves, self dot waypoint y moves, self dot waypoint x moves, self dot waypoint x moves. Okay, and now action L means to rotate the waypoint around the ship left counterclockwise the given number of degrees. So L rotate the waypoint around the ship the given number of degrees. Okay, so what I will do is I will say num turns equals, and again, let me make sure these are all positive numbers, 180, 270, and so on. So num turns equals action dot amount divided by 90, and then for blank in range num turns, I want to move it, rotate it left counterclockwise. Okay, and so let me just see what these all R80, R180, R90. I'm just going to write these out by hand because that'll be simpler. If action dot amount equals 90, so to rotate 90 degrees, so xy goes to minus yx, and does that always work? I think that does. So we'll see if this works. For turn in range action dot amount divided by 90, and let's say waypoint dot x waypoint dot y equals minus waypoint dot y waypoint dot x, and that's self dot waypoint dot x. There's a possibility that self dot waypoint x. There's a possibility that I'm getting this wrong, and if that's the case, we'll fix it. But I think I'm probably getting it right. Okay, and then otherwise, if action dot action equals r, and again, I want to do the same thing, except now I want to say, I think it's the opposite, this and minus that, right? So if I start with, 1, 1, then, or let's say I start with, 2 over 1 up and I rotate it, then I want to go to 1 over and 2 down. So that seems right as well. And then finally, if action.action equals F, move forward to the waypoint. The waypoint is relative to the ship. That is, if the ship moves, the waypoint moves. So it moves the ship to the waypoint 10 times. A total of 100 units east and 10 units north. Leaving the ship icy. So otherwise, the action equals F. Self dot ship X plus equals action dot amount times self dot waypoint X, and self dot ship Y plus equals action dot amount times self dot waypoint Y, and that's that. So now again, let's make another ship. Ship 2 equals ship. Actually, let me call it S. Saw equals ship and waypoint. For action in actions, saw dot move action, and its Manhattan distance is 286. So assert ship dot saw dot ship X equals 214, and assert that saw dot ship Y equals minus 72. So that's what he says, and let us try that. Okay, so that worked too. So now saw equals ship and waypoint. For action in actions, saw dot move action, print abs saw dot ship X plus abs saw dot ship Y. Okay, and now let's try that. And it says 48,739, so let's copy that. And okay, that's the right answer. 1 gold star closer. Okay, good. So that was reasonably straightforward. Here, what were the tricks, or what did we do? So one is that I used a data class. Even though a couple of videos ago I said never use a data class. So why did I use a data class? I used a data class because I wanted to mutate X and Y in heading by changing it and so on and so forth. And name tuples are quote unquote immutable, which means you have to like create a new one. So if I use name tuples, I would basically have to say one move would have to return a new ship, and it'd have to say like return self dot replace self dot Y, like basically return self dot replace Y equals self dot Y. Anyway, it would have been a mess. So this is one of the cases where you want to use mutation. And then just like keeping a picture in my head, I'm going to treat this like the unit circle and call my variables X and Y just like I would in the unit circle, so that an angle of 0 is the positive X direction, an angle of 90 is the positive Y direction, an angle of 180 is the negative, and so on. So so that makes it easy to move these based on these directions. And then if I want to turn, again, left is increasing angle, so I add the amount, and then I just mod by 360, because once I do go 360 degrees, I'm all the way around the circle. And then finally, to move forward, I just, depending on the heading, again, heading 0 means I'm facing east, so I increase X, heading 90 is up, so I increase Y, and so on and so forth. And so then it's just really a matter of parsing in these actions and doing them and then figuring out where I end up. The second point was interesting because you have this ship, and you also have this waypoint kind of relative to the ship that the waypoint is always relative to the ship. So I don't think I appreciated that, but I somehow got it right anyway. So north says move the waypoint further away from the ship, and so on. And then for the rotation, it's just a matter of, probably the tricky part is knowing to do this. And how did I know to do this? I just know that, when you have something and you rotate it 90 degrees, you basically two things. One, you swap the x and y, and then you swap one of the signs. And then, but I can't remember which it is, and so I just basically reason from examples. If I start with the point that's 2 over and 1 up, it's going to go to the point that's minus 1 over and 2 up. So that tells me what I need to do with the negative signs and vice versa. So moving the waypoint, and then the forward is the interesting one, where basically I move in the direction of that waypoint, but it stays the same place relative to me. So, I think this was like a relatively straight, like you can see that there's nothing exciting going on here from like a computer science, data structures, algorithms perspective. It's really just follow the instructions. But it's just attention to detail and getting the angles right and getting the movements right and things like that. So it worked, easy enough, awesome. And I will stop recording and see you next time. All right. Thanks for watching.